Teacher Dolly here. Welcome back. If you're new to my channel, please subscribe and click the notification button. In today's video, we're going to discuss about the calculation for speed, distance, and time. So we have the lesson objectives for this video, and here students are expected to be able to calculate speed, distance, and time. Now let's first define speed. And the definition is, speed is the distance traveled per unit of time. If we're going to write that definition in terms of an equation or formula, then we're going to have this. Speed equals distance divided by time. So that line there would mean the per in the definition. So it is distance per time. Okay. We have an example here. The bus travels 140 kilometers in 2 hours. What is the speed of the bus? Now, in solving word problems like this, we need to find the given facts. So we need to write them down. So we have 140 kilometers is the distance, and time is 2 hours. We're looking for the speed. So we can get the formula, which is that, and all we need to do is to substitute and evaluate. So speed, we write down 140 to replace distance, and 2 hours for time. So dividing 140 by 2, we're going to get 70. And what is the unit? Kilometers per hour. All right. There is one question that comes with this problem, guys. Is the bus always traveling at a constant speed of 70 kilometers per hour? Meaning the speed did not change for 2 hours? The answer is no, it's not constant. So we have the bus maybe at some point or points increase the speed or accelerate, and maybe at some point or points the bus decreased in the speed, so decelerate. So we are actually looking at the average speed in this one, guys. Okay, so it is equal to the total distance divided by time. That's the average speed. So the 70 kilometers per hour in here would mean it's the average speed. And it does not mean that the bus just maintained 70 kilometers for 2 hours. All right, so now we have the SDT formula. So we have this, and we're going to get the formulas for the 3 factors we're looking at. Speed for the first one. We have equation is distance divided by time. And the next one, you have, you're looking for the distance. It is speed times time. And you have, you're looking for the time. It's going to be distance divided by speed. So now let's go to some word problems. Demo number 1. So you still have that, and we're looking for the speed. So here, a car travels 300 kilometers in 3 hours. Calculate the average speed. So we have to list down the given information. 300 kilometers, the distance, and 3 hours is the time. We're looking for the speed. Now, we have to check, do we need to convert any of the units? Okay, so at this point, we don't need to. Okay, so we're ready to get the formula, which is that it's always safe and good to write down the formula. And after that, we're going to substitute and evaluate, okay? So now you have 300 for the distance and 3 for the time. And so dividing those two values, you have 100. And the unit would be kilometers per hour. All right. Now let's look at a second problem here. A train travels 255 kilometers in 90 minutes. Calculate the train's average speed. So that's the train. Again, we need to list down the given information. 255 kilometers is the distance, 90 for the time. So if we look at the units given, so we're going to, if we're going to find the speed, then it's going to be kilometers per minute. And it's more appropriate if we say kilometers per hour. Therefore, we need to change this into hours, okay? So convert 90 minutes to hours, and we can do that by dividing it by 60. And so we have 1.5 hours for that time. Now we're ready to write down the formula, and then we're going to substitute and evaluate. So you have that, and so 170 kilometers per hour. So in solving such problems, guys, we need to check whether we need to convert any of the units or we don't need to, okay? Now demo number 2. So we're looking for the distance, okay? So it's multiply. Jim drives at 65 kilometers per hour for 3 hours. How far does he travel? Okay, so again, given, and then find the distance. So convert units? No, we don't need. Write down the formula. Distance, speed times time, and then we can substitute and evaluate. All right, so 195 kilometers. So you can see how easy it is if you're going to follow the steps. So write down the given, check if there are units to be converted, write down the formula, substitute. Okay, so pretty straightforward. Okay, another problem. For 15 minutes, Sally ran at an average speed of 20 kilometers per hour. What distance did she run? Okay, so again, write down the formula, and looking at the units, you have minutes and hours. So in this case, we need to really convert the time for the time into kilometers, into these hours, okay? So you have distance we're looking for because it's obvious, it says what distance. All right, so we'll check, we need to convert. So 15 over 60, and that is 0.25 of an hour. Okay, write down the formula. And then you're now ready again to write down and substitute and evaluate. So we have 20 times 0.25, that is 5 kilometers. All right, so 5 kilometers in 15 minutes. Okay, demo number 3. So let's go for that. And we're looking for time. Okay, So a train travels 300 miles at 60 miles per hour. How long? So how long would mean the time. All right, given again, you have to list them down because as I have said earlier, that is very important. Okay, so find the time, check your units, then not, okay, write it down, the formula, and then substitute and evaluate. So 300 divided by 60, which is the speed. So you have 5 hours. Okay. So now let's go to the next. A runner travels 3 kilometers at 5 meters per second. How long does the runner take? All right. So looking at the units here, let's first write down the given. So kilometers here is the distance and speed is meters per second. Again, we need to do some conversion before we can proceed. Okay, we're looking for time in here and we need to convert the units for the kilometers. So you have 3 times 1,000 because there are 1,000 meters in 1 kilometer. Therefore, your 3 kilometers is equivalent to 3,000 meters, okay? So now we're ready to just get the formula and substitute and evaluate. So you have 3,000 divided by 5. So you have 600 seconds. Now 600 seconds, we can convert that into a bigger unit, which is minutes, by dividing it by 60. So we get 10 minutes. Okay, let's go to a more complex problem, a combination of problems here. Okay, the distance from Oliver's house to university is 8 kilometers. He can travel by bicycle at an average of 20 kilometers per hour or tram at 16 kilometers per hour. How much longer will the journey take if he decides to take the tram? So there are 2 cases here. So first one, by bicycle. We write down the given facts around that by bicycle and then find the time. So you have the formula, distance divided by speed. Okay, so 8, the distance divided by 20, which is the speed. 0.04 of an hour. Now we can change that into minutes by multiplying it by 60. So 24 minutes. So Oliver travels for 24 minutes to get to the university from home. Okay. Next one, by tram. So given that, again, we're getting the given information first, and then we have distance divided by time, 8 over 16. So you have 0.05. Same thing, we need to change it to minutes, so that's 30 minutes. So you can see here the difference of travel time. By bicycle, 24, and by tram, it's 30. So, okay, by bicycle, it takes Oliver 24 minutes, and by tram, it's 30. Therefore, the answer is Oliver travels 6 minutes longer if he takes the tram. Thank you for watching my video today, and I'll see you in my next video. Bye for now.